Hi friends, today's agenda will be discussing about a numerical problem based on Kirchhoff's law. Uh, Again, this is one of the problems which I have found that majority of you all want to run away somehow from this particular type of numericals based on Kirchhoff's law. So today I would like to discuss this problem which has been taken from the paper ISC 2016, and most of the time in board's paper you will find that this numerical problem will be present. So here you have got here's the circuit that has been shown to you. There are two batteries of 2 volt and 3 volt together, and the question asks us to find out the current I1 and I2 flowing in this particular circuit. So I'm not marking the current presently. I would like you to understand how we should proceed in order to solve the Kirchhoff's law. Again, I would request you to visit the theoretical video also based for the Kirchhoff's law to have that proper understanding how we are going to proceed to solve or apply Kirchhoff's law in our numerical problem. Now, the first step for solving Kirchhoff's law is to begin with by marking the currents. Now, as many number of batteries you find into the questions, please draw the current into the circuit. Remember, the currents divide only at the nodes, so before the nodes please do not divide the current. So you can see here there is a one battery of 2 volts. So what I'm going to do, I'm going to draw the current. This is the current I1, and this current I1 will get divided at the node. There is no node over here, this is only a point. So here, from here, the current I1 goes in this part of the circuit, and if, as you can see, this is the branch which is continuing, the current is going to remain the same, I1, and here are the two nodes where the current distribution is going to take place. So the entire current in this branch will be I1. Similarly, in the second branch, if you see, this is the second branch, so here the current is, again there is a battery. I will draw the current. Remember, the current is always drawn from the positive of the battery, so this is the positive, and similarly this becomes the positive. So here the current will be I2. The current goes in this branch also as I2. So remember, the current I2 in this branch, and this is again I2. Sorry, the current is going to remain the same, I2. So remember, if the branch does not change, the current remains the same. So this, in this entire branch I2, and in this entire branch the current I1. This is the node where these two nodes comes. There are two currents coming, and they will flow into this particular branch as the sum of I1 plus I2. Remember, branch as simple as the road. This is the cross. Now here, if there is a number of some certain number of charges coming up or the current continuing, the same current is going to flow in this entire branch I1. Similarly, the same current will flow in this entire branch I2. At this node, they two combine together and they begin to flow from top to bottom, and that is I1 plus I2. That's the first step. Draw the current from each part of the battery and distribute it at the nodes. Now after that, start marking the points and the nodes or the junctions as 1, 2, 3, 4 and so on. So I will begin by marking it the point. This is the point 1, this is the 2, this is 3, this will be 4, this is 5, and this is 6. So we will mark all the points or the nodes and the nodes or junction. I have done that. Now, as many, step 3 says, as many number of current variables you have got, choose that many number of meshes. You can see in this particular circuit I have got two number of variables, current variables, namely I1 and I2. So I will be choosing two meshes. The first mesh that I am going to choose will be 1, 2, 5, 6, 1. And see, I have written down 1, 2, 5, 6, 1 as I am going to travel in the mesh. So 1 to 2, 2 to 5, 5 to 6, 6 to 1. This is the direction of travel and is independent of the direction of current flow. So this is my direction of travel. And the second mesh that I am going to choose may be 2, this one, 2 to 3, 3 to 4, 4 to 5, 5 to 2. Again, this is the second mesh, and this is the direction of travel. Remember, I am choosing the direction of travel independent to the direction of flow of current. Now, when I am traveling in a mesh, if I go along the direction of current and if I meet a circuit element such as resistor, capacitor or inductor, the potential drop would be written with the negative sign if I go along. So how do you remember that? Remember, along Ng comes negative, and if you are traveling opposite to the current flow, opposite, P comes, so positive. If you are traveling along the current flow, mark it with a negative, give that potential drop a negative sign, and if you are moving opposite to the current flow, write down the potential drop with a plus sign. Let me show it to you. So let me solve it out for you. 1 to 2, if I travel, there is no circuit element, so forget about it, there is nothing to be done over there. 2 to 5, if you notice, when I am traveling from 2 to 5, you would find that from 2 to 5 I am traveling along the direction of current, isn't it? And if I am traveling along the direction of current, the potential drop will be written with a negative sign, so minus I into R, I1 plus I2, and what is the R? R happens to be 2. Now, when I go from 5 to 6, there is no circuit element, so no potential drop. And then similarly, when I go from 6 to 1, you would notice when I am traveling from 6 to 1, I go along the direction of current, I meet a circuit element, that is the resistance, and the potential drop again being along will be minus 1 into I1. And then when I move out of the battery, remember from the side where you exit, so when I go from 6 to 1, I move from the positive terminal of the battery, move out of the positive terminal of the battery, so I will take it plus 2 is equals to 0. Remember, when you are mentioning the EMF of the battery, it must always be mentioned from the plate from which you exit the battery. So since when I'm moving from 6 to 1, I'm exiting the positive terminal of the battery, so I'm writing it down as plus 2. Similarly, if I go with 2 to 3, you would notice there is no circuit element. 2 to 3, there is no circuit element. From 3 to 4, you would notice that I'm moving from 3 to 4, I am going to exit the battery from the negative plate, so I'm going to write down as minus 3. When you are writing down the potential drop of the battery or the EMF of the battery, it is going to be independent of the current flow. Independent. You don't look at the current flow. You look the current flow only for circuit elements. So remember, this sign convention will be applicable only for circuit element. Applicable for circuit element and not for batteries. Batteries are always mentioned independent of the current flow. Now let's move further ahead. Now when I go from 3 to 4, you find that I am going to go through this resistor of 6 ohm. Now when I am talking about resistor, again remember it's a circuit element, so I am going to go opposite to the direction of flow. The current flows from down to up and I am moving from up to down, so I am going opposite, and whenever I am going to go opposite, I am going to write down with a plus sign. So plus potential drop will be I into R, so it will become I2 into R being 6, the I2 into 6. Then 4 to 5, there is nothing, and from 5 to 2, again when I go opposite to the current flow, so being an opposite to the circuit opposite to the current flow, so the potential drop across the circuit element would be I1 plus I2 into 2 is equals to 0. So that's the way we are going to frame the equation. So I have framed the two equations. Now I have to solve them and then get the answer for the problem. I have simplified this two equations. I have transferred this on the other side. So 2 is equals to 2i1 plus i2 plus i1, and on opening the bracket it is 2 is equals to 2i1 plus 2i2. And similarly, when I am going to simplify this will become 6i2 plus 2i1 plus 2i2 is, and I'm transferring 3 on the other side, that will become 3. So 2i1 plus 8i2 is equals to 3. Now this is my second equation, and this will be my first equation, this will be my first equation. So solving them separately, so this can be rearranged as now. The first equation is 3i1 plus 2i2 is equals to 2, and the second equation is 2i1 plus 8i2 is equals to 3. Solve it simultaneously. You can see what I can do. For i2, I am going to multiply the above equation by 2, and I am going to multiply it by 3. So it will be 3 2s are 6i1 plus 2 2s are 4i2 is equals to 2 2s are 4, and 3 2s are 6i1 plus 8 3s are 24i2 is equals to 3 3s are 9. This is minus, and this also as a minus, cancels out. 24 minus 4 is minus 20i2 is equals to minus 5, or simply i2 is equals to 1 by 4 ampere. Here what I can do, again rewriting the same equation, 3i1 plus 2i2 is equals to 2, and 2i1 plus 8i2 is equals to 3. What I'm going to do, I'm going to multiply it by 4, and I'm going to multiply this equation by 1. So 4 3s are 12i1 plus 4 2s are 8i2 is equals to 4 2s are 8, and 2i1 plus 8i2 is equals to 3. Minus and minus, again this cancels out. I get 12 minus 2 as 10i1 is equals to 8 minus 3 as 5. Therefore i1 is equals to 1 by 2 ampere. So that are the two answers. Thank you, boys and girls. So I hope that would have solved your problems for Kirchhoff's laws.